A Geographic Information System, GIS, is a computer-based system used to collect, store, manage, and display information related to locations on the Earth's surface. It can combine different types of information such as roads, buildings, rivers, and vegetation on a single map. This helps people easily view, analyze, and understand patterns and relationships between different geographic features. Types of Geographic Information System data. GIS data is mainly of two types, vector data and raster data. Vector data represents geographic features using points, lines, and polygons. Points show specific locations like schools or wells, lines represent features such as roads, rivers, and railways, and polygons indicate areas like forests, lakes, or administrative boundaries. It is useful for showing clear boundaries and precise locations on maps. Raster data represents the Earth's surface as a grid of small cells, pixels, where each cell contains a value representing features like temperature, elevation, rainfall, or land cover. It is commonly used in satellite images, aerial photographs, and environmental studies, especially for showing continuous features such as climate patterns and terrain. Geographic Information System applications. GIS is widely used in many fields because it helps in analyzing geographic information and improving planning and decision-making. Urban planning, GIS plays an important role in city planning and development. It helps planners map land use and divide areas into residential, commercial, industrial, and recreational zones. It also supports infrastructure planning by analyzing population distribution, terrain, and existing facilities. Environmental management, GIS is very useful for protecting natural resources and monitoring environmental changes. It helps track deforestation and changes in forest cover using satellite data. It can also identify sources of pollution in air, water, and soil. In wildlife conservation, GIS helps map animal habitats, migration routes, and areas affected by human activities, which supports better conservation planning. Disaster management, GIS is an important tool in disaster management because it helps in preparedness, response, and recovery. It can identify areas that are prone to floods by studying elevation and river systems. For earthquakes, GIS helps locate fault lines and identify vulnerable buildings and populations. During disasters, GIS can assist in planning evacuation routes, locating relief camps, and coordinating rescue operations. Agriculture, GIS supports modern agriculture by helping farmers make data-based decisions. It is widely used in precision farming, where farmers analyze crop health, soil quality, and irrigation needs. GIS can also help study soil fertility, moisture levels, and pH values. Space research, GIS is also used in space exploration and planetary studies. Scientists use GIS to create maps of celestial bodies such as the Moon and Mars. These maps help researchers study surface features and choose suitable landing sites for space missions. When combined with remote sensing data, GIS helps scientists analyze both Earth's surface and other planetary environments. Government initiatives related to GIS in India. The Government of India has launched several initiatives to promote the use of Geographical Information System, GIS, and geospatial technology for better planning, governance, and development. These initiatives help improve land management, infrastructure planning, disaster response, and digital governance. National Geospatial Policy 2022 aims to make India a global leader in the geospatial sector by promoting the use of geospatial data, developing geospatial infrastructure, improving skills, and encouraging private sector participation. Svamitva scheme uses GIS and drone mapping to provide property cards to rural households and digitize land records. It helps reduce land disputes, improve financial inclusion, and support rural planning. Bhuvan, a geoportal developed by Indian Space Research Organization that provides satellite imagery and geospatial data for applications such as disaster management, environmental monitoring, and development planning. Bharat Maps, developed by the National Informatics Center, This multi-layer GIS platform supports e-governance and digital infrastructure projects. Survey of India Online Maps and Data Portal provides digital access to topographic maps, geospatial data sets, and mapping tools for government agencies and the public. Gram Manchitra, a GIS-based platform by the Ministry of Panchayati Raj that helps Panchayati Raj institutions prepare village development plans using spatial data. Geospatial Energy Map of India, launched by NITI with Indian Space Research Organization. It provides GIS-based information on India's energy resources and infrastructure to improve energy planning. Sarthi Web GIS Platform. Sarthi Web GIS is a web-based GIS platform designed to provide interactive maps and data visualization tools. It helps policymakers and planners analyze geographic information and make better decisions in sectors such as infrastructure development, environmental monitoring, and public administration. GIS implementation challenges. Inadequate data quality. Lack of accurate and updated geospatial data can lead to incorrect analysis and poor planning decisions. High cost. GIS systems require expensive software, satellite imagery, GPS devices, and data storage, along with regular maintenance. Lack of skilled personnel. There is a shortage of trained professionals who can analyze spatial data and manage GIS technologies effectively. Privacy and security concerns. GIS data may include sensitive location information, creating risks of data misuse, unauthorized access, and cyber attacks. Data integration issues. Combining data from different sources and formats can be difficult and may affect the accuracy of analysis. Measures to strengthen GIS in India. Use of advanced technologies. Use satellites, drones, IoT sensors, and technologies like artificial intelligence and machine learning to improve data accuracy and real-time updates. Promote open-source software. Encourage affordable tools like QGIS to reduce costs and increase accessibility. Training and skill development. Expand GIS education and training to create more skilled professionals in the geospatial sector. Increase geospatial investment. Support startups, innovation, and infrastructure development in the geospatial industry. Develop indigenous technologies. Promote domestic GIS software and hardware to reduce dependence on foreign technologies. Strengthen data protection. Implement strong cybersecurity and data protection measures to protect sensitive geospatial data.